So today, we're going to track 4 really incredible stories that, when you put them together, they actually show you the entire life cycle of AI innovation. We're going to go from these little digital breadcrumbs that hint at a secret new model, all the way to an AI that's been battle tested in, well, the toughest coding environment you can imagine.
Okay, so here's our journey. We're starting with a mystery that some eagle-eyed developers uncovered. Then we'll look at a powerful new tool that's just been released for everyone. After that, we dive into some mind-blowing research on emotion. And we're going to finish with a model that was literally forged by failure.
All right, so first up, we're diving into some classic digital detective work. This isn't some big press release from DeepSeek. No, this is about developers on GitHub noticing something big that the company probably didn't want us to see just yet. So, picture this. It's January 20th, 2024, and a huge code update just drops. We're talking 114 files changed. And buried deep inside all that new code were these little hints of what looks an awful lot like the company's next major flagship model. And this is where the clues really start to pile up. All through the code, there's this mysterious identifier, Model 1, and it's always treated as something separate from their current model. But more importantly, you see these fundamental changes to core components. They're redesigning the KV cache, which is basically the model's short-term memory, and adding support for new, faster data formats like FP8. These aren't just minor tweaks. These are signs of a major architectural overhaul. So when you put it all together, the evidence is pretty strong. This doesn't look like a simple DeepSeek v3.3. This looks like the foundation for v4.0. The way the code itself separates Model 1 from the existing architecture, it's like they're building a whole new house right next to the old one. It really seems like a true successor is on the way. Okay, so we go from something secret, something being built in the shadows, to a model that's just been thrown right into the spotlight. Zipu AI has just released GLM 4.7 Flash. And what's so cool about this one is that it's not just powerful for coding, it's designed to be accessible and practical enough for pretty much anyone to use.
So how do they pull this off? Well, it's all about this clever architecture called Mixture of Experts. The model has 31 billion parameters in total, which is absolutely massive. But because of this MOE design, it only activates the specific expert parts it needs for any given task. This makes it incredibly fast and efficient, but without losing all that power. It's kind of like having a whole team of specialists, but only calling in the one you need.
And then there's its other killer feature, a massive 128,000 token context window. Now, to put that into perspective, that lets the AI hold an entire software project or a really long, complex report all in its active memory at once. For tackling big coding problems or analyzing long documents, this is an absolute game changer. And of course, you can't have a new model without some big claims, right? Zipu AI is positioning this thing as a leader, especially in reasoning and those long horizon tasks, while still being right up there in math and coding. It's making a serious case for being the go-to tool for developers who want a powerhouse that's also easy to work with. Now we're going to shift gears pretty dramatically. We're moving away from commercial products and into some really fundamental science. This is a story about some incredible research out of Japan that asks a fascinating question. Can an AI learn to understand what an emotion is just by looking at our body's raw signals, without anyone ever telling it, this is happiness or this is fear? So this whole experiment is built on a really fascinating psychological idea called the theory of constructed emotion. The gist is that feelings aren't these pre-programmed things in our brain. Instead, your brain literally builds them on the fly by interpreting signals from your body, like your heart rate, and mixing that with what's going on around you. So here's how they tested this idea. They basically fed an AI 3 raw, completely unlabeled streams of data. You had the images people were looking at, their physiological responses, heart rate and so on, and the actual words they used to describe how they felt. The key here is that the AI had no idea what any of it meant. Its only job was to just find the patterns, find the hidden connections on its own. And the results? Honestly, they were stunning. The emotional categories that the AI figured out all by itself matched what the humans actually said they were feeling about 75% of the time. I mean, that is so far beyond random chance, it really suggests the AI was tapping into the real underlying structure of how we experience emotion.
So what's the big deal here? Why does this matter? Well, the real-world implications are huge. Think about AI that could provide way better mental health support or assistive technologies for people who struggle to communicate. The goal isn't to create an AI that feels. No, it's about building one that can recognize the incredibly complex patterns of our emotional states, especially when we can't even find the words to describe them ourselves.
All right, for our last story, we're ending with something really tangible, something forged in fire. We're talking about an AI built for the brutal, unforgiving world of competitive programming, a world where your code either works perfectly or it fails completely. There is absolutely no middle ground. The training method here was, well, it was brutally simple. The AI would write code to try and solve a problem. Then that code was immediately run against a whole bunch of hidden tests. If it passed every single one, it got a point, a positive reward. But if it failed even one, or timed out, or used too much memory, it got a negative one, punishment. And you can see the results of that tough love right here. This brutal feedback loop boosted the base model's performance by over 7 percentage points on a really difficult benchmark. In the world of AI performance, a 7-point jump is a massive leap forward. It just proves that this trial-by-fire approach really works.
But let's be clear, this wasn't just about punishment. The whole training setup was incredibly smart. All the code ran in these safe, isolated containers so nothing could break. And they even prioritized the hardest test cases first, which helped the AI find its failures and learn from them much faster. The whole system was just designed to force learning at maximum speed.
So let's pull it all together. Today, we've traced the entire arc of AI innovation. We started with the secret whispers of a new foundation being built at DeepSeek. Then we saw a powerful tool released for everyone by Zipu. We shifted from building better machines to understanding ourselves with research that decodes human emotion. And we ended with NewsCoder, a testament to the harsh, logical reality of making AI that actually works. And that brings us to a really provocative final thought. What if the key to truly intelligent AI isn't just about feeding it more and more data, but about creating these environments where it can safely and brutally